This is for Year 12 methods. It comes out of the Year 12 2014 functions revision. It's the Kubaha exam 2, question 2. Diagram below shows the graph of this hyperbola. What we need to do is label the axes, label the asymptotes, put the equations and the asymptotes. If you set x equal to 0, you get 3, therefore that's 3, which means each guiding line is 2. Accordingly, you can put on a scale. For point B, set it equal to 0, therefore x equals 6. And if that's 6, therefore each guiding mark is 2, so you can put on the scale accordingly. Point P has a coordinate k and f of k, where k is positive and the function is positive. So, k can only go from 0 to 6, not inclusive of 0 because it's got to be positive, and not inclusive of 6, so k goes from 0 to 6. Find the value of k if the tangent on the curve of point B is parallel to the line segment from A to B. Line segment from A to B has 0, 3, 6, 0, goes down 3 and over 6, therefore it's got a gradient of negative a half. So what I need to do is I need to take my function, which is 8 over x plus 2 minus 1, and I wish to take its derivative with respect to x, and I want to set that equal to negative a half, and I wish to solve it. That gives me negative a half, and that gives me two answers, negative 6 and 2. Since k goes between 0 and 6, 2 is my answer, so k equals 2. Find the value of k corrected 3 decimal places if point P is closest to the origin. If point P is closest to the origin, therefore the distance from there to there has to be a minimum. So I'm going to set up the difference rule, distance formula, take its derivative and set it equal to 0. Okay, so I have one point which is 0, 0, and the other point is k, and then 8 over k plus 2 minus 1. So I'm setting up the difference, so I'm going to have this, which will be, I'm going to use x instead of k, x squared plus bracket, I'll take this, and close the bracket and square it. Okay, so that's what's under there. I need to take that, take its derivative with respect to x, set it equal to 0, and solve for x. It gives me minus 4 and 1.1880. Since k is between 0 and 6, 1.188 is my answer for k. The tangent of the curve at point P crosses the y-axis at point C and the x-axis at point D. Write down, in terms of k, the coordinates of C and D. Well, if I have the tangent at point K, then I find its x and y intersect. So, this is my rule. I'm going to copy that. I'm going to calculate a tan line, interactive calculation line, tan line at point K. Okay, that's the equation of the tan line. So there it is there. Its y-intercept will be this. So point C is that. Now if I take that and I go interactive transformation combine, that gives me this, which is what that is. And if I go back up here to the tan line, this is the tan line, and notice there's an X there, so if I copy that, the whole equation, and I paste it, when that equals 0, that will give me the x-intercept. So I take that and I solve it for x. And that gives me that expression. And if I take that and I combine that, there is the x-coordinate. Okay. Part 2, find in terms of k an expression for the area of the triangle. It's going to be a half times base times height. Half the base will be this one is the base, and that's the height. Write that or that. Find the value of k when the area of the triangle is maximum. Okay, if I take this and take it, so I'm going to have 0.5 times this times this. And there is this expression. If I take that, take the derivative with respect to k, I set it equal to 0, and I solve it for k. And I get these answers, and the only answer with k between 0 and 6 is 2. Therefore k equals 2. And over the page in E, find the value of k correct for 3 decimal places if the normal to the curve at point P passes through the origin. So I've got point P, its normal passes through the origin. I can get an expression for the gradient two ways, rise over run, so that will be the y coordinate divided by k. That's one expression for gradient. The other expression for gradient will be take the derivative of this, sub k in is the x value, and then flip it upside down and times by -1. So the derivative of f dash is -8 on k plus 2 squared, and that comes from, here is my expression, copy, paste, and I take the derivative of it with respect to x, and there it is. Now, I don't want this because I wish to flip it upside down and change the sign. So, I actually want so that, what do I want now? So, I'll get rid of that. I've got bracket x plus 2 squared over 8, and that equals, and here I've got a fraction 8 on top of x plus 2 minus 1 in the numerator over x. And I need to solve that for x. And that gives me two answers, and the answer that I wish for k in this case is 1.188 because that gives k between 0 and 6.